Here's a picture I thought was cute. So you got a fluffy little cat, and then you got like a drenched, skinny, scrawny looking little cat. And I wanted to compare that to the two integrals that I have written below. Now, when I first look, let me scroll up so that's not in the way anymore. When I first look at this, at first glance, it looks like it's going to be complicated. Now, this is something you'd see in a first-year calculus class or maybe an AP calculus class in high school. So let's go through how we would deal with this. Now, this is a u-substitution problem, and here we go. First off, let's let u be equal to this guy right here. So that's going to be sine of the square root of x. Now let's take the derivative and get du. Du is cosine of the square root of x, but then by the chain rule I have to take the derivative of square root of x also. So think of it this way. The derivative of sine is something, is cosine of something, times the derivative of that something. So that's going to be times 1 over 2 square roots of x, okay, dx. And when I rewrite that, du is going to be equal to cosine of the square root of x over 2 square roots of x dx. And now what I notice is if I look right here, that's literally the same exact thing as I have right there. Now it's not always going to be exactly the same, and we might have to adjust it from time to time, but right now this is perfect. So I can make a complete substitution. That's why they call it a u-substitution. So I can now rewrite this as the integral of e to the u, because let's not forget that u was sine of the square root of x, du, because all of that gets replaced with du. So it's important how you choose your u, because when you choose your u the right way and you make your u substitution back, it turns it into a really simple integral, which is why the picture up here, right? This cat here has a lot of fluff all over him. This cat is the fluff stripped away, and it stands for the pretty basic integral. So when I go out and finish this, the integral of e to the u du is just e to the u plus a constant. And then when I put u back in with what it is from up here, I end up getting e to the sine of the square root of x plus a constant. And that is a solution to that integral.